Welcome to our latest video on the topic of making salts from acids and metal carbonates. This video is suitable for GCSE students. By the end of this video lesson, you should be able to recall how salts can be made from reacting acids with insoluble bases, alkalis and metals, and understand how neutralization reactions can be summarized by a simple ionic equation. You should also be able to understand that metal carbonates react with acids to form metal salts, carbon dioxide gas, and water, and be able to explain how crystals of soluble salts, such as copper 2 sulfate, can be obtained by this reaction. Finally, you should understand that the acid-carbonate reaction is often used as a chemical test for acidic substances and a carbonate ion. In our previous lessons in this topic, we've learnt that salts are chemicals made from acids, and in a salt, the hydrogen atoms in the acid are replaced by metal atoms. For example, hydrochloric acid has the chemical formula HCl. Sodium chloride is a salt made from hydrochloric acid, and its chemical formula is NaCl. The hydrogen in hydrochloric acid has been replaced by the metal sodium. Sulfuric acid is a chemical formula H2SO4. Magnesium sulfate is a salt made from sulfuric acid and has the chemical formula MgSO4. Once again, the hydrogen in the acid has been replaced by a metal, in this case magnesium. And finally, nitric acid has a chemical formula HNO3. Its salt is potassium nitrate here, and that has the formula KNO3. Once again, the hydrogen in the acid has been replaced by a metal atom. The name of the salt depends on the acid. If it's a chloride, it's made from hydrochloric acid. If it's a sulfate, it's made from sulfuric acid. And if it's a nitrate, it's made from nitric acid. Now, in our previous lessons, we learnt that salts can be made from reacting acids and bases together. And when you react an acid and a base together, you make a salt and water. Now remember that acids are substances that split up into H+ ions when you put them in water. And a strong acid totally splits up into H+ ions, while a weak acid partially splits up into H+ ions. We've also learnt that a base is the opposite of an acid, and if that dissolves in water, it's classed as an alkali. Now, when an acid and a base react to form a salt and water, a neutralization reaction takes place. Now, to understand neutralization reactions a little better, we can use ionic equations. First of all, let's look at this word equation. We have sodium hydroxide, which is a base. It's actually a soluble base, so it's classed as an alkali, reacting with hydrochloric acid to form the salt, sodium chloride, and water. If we wrote a chemical equation here, we'd have NaOH plus HCl forming NaCl and H2O. Now we can also use an ionic equation to describe this reaction, and the ionic equation is a lot simpler than the chemical equation. So in the ionic equation, we have H plus from the acid, because acids split up into H+ ions, reacting with OH- ions from the alkali to form water, H2O. And you'll notice there's state symbols here. AQ means aqueous and L means liquid. Notice that in this ionic equation, we don't include the sodium ions and we don't include the chloride ions. And this is because these are spectator ions. They don't take part in the main reaction for neutralization. The main neutralization reaction involves H+ ions reacting with OH- ions to form water. Now, in our previous lessons, we've also learnt that salts can be made from the reactions of acids and metals. And for a metal to react with an acid, it must be more reactive than hydrogen. Now, when a metal reacts with an acid, it forms a salt and hydrogen, and the more reactive metal kicks out hydrogen from the acid. So if we look at this word equation, we have magnesium reacting with hydrochloric acid to form magnesium chloride and hydrogen gas. And this reaction works because magnesium is more reactive than hydrogen. Now, metals such as copper are less reactive than hydrogen and therefore are not able to react with acids to form salts and hydrogen, because metals such as copper can't displace hydrogen from acids. Now, in this lesson we're going to look at how we can make salts from the reaction of acids and metal carbonates. But before we do this, let's test your understanding of what we've covered previously and in this lesson so far with some practice questions. So here's the first set of practice questions. Read for the questions, pause the video, have a go at them, and then we'll go for the answers. So now let's go for the answers to question 1. So this first question is asking you to explain the difference between a strong and weak acid. Now this is a 2-mark question. Now strong acids totally split up into H+ ions when placed in water. Remember, H+ ions can also be called protons. So if you said that, there's 1 mark. Weak acids only partially split up into H+ ions or protons when placed in water. There's 1 mark for that. So that's the difference between strong and weak acids. For part B, it's asking which of the following substances are strong acids. Now, from this list, hydrochloric acid is a strong acid and sulfuric acid is a strong acid. So 1 mark for each of those. For reference, ethanoic acid and citric acid are both weak acids and ammonia is a base. So here's our second practice question. Once again, read for the question, pause the video, have a go at it, and then we'll go for the answers. So question 2 is asking you to complete the following word equations. So acid plus base will produce a salt plus water. Acid plus alkali will also produce a salt plus water, because remember, an alkali is just a soluble base. And acid plus metal produces a salt and hydrogen. 1 mark for each of those. So here's our next practice question for you to have a go at. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So let's go for the answers. So calcium hydroxide is a base, and when it reacts with hydrochloric acid, it forms a salt and water. Because it's calcium hydroxide, we're going to form a salt that starts with calcium, and because it's hydrochloric acid, we're going to form a salt that is a chloride. So that's why we get calcium chloride plus water. For part B, we have potassium oxide and nitric acid. Once again, potassium oxide is a base because bases are metal hydroxides or metal oxides. The salt's going to be a nitrate because it's nitric acid, and it's going to be potassium nitrate and water that forms. For C, we have a metal, not a base this time, reacting with an acid. So we're going to form a salt and hydrogen, and the salt is going to be magnesium sulfate because sulfuric acid forms sulfates. Zinc plus nitric acid, again a metal and acid, form a salt and hydrogen. So therefore the salt is going to be zinc nitrate plus hydrogen, because nitric acid leads to the formation of nitrates. And then our last question, we have iron hydroxide and metal hydroxide, so it's a base. Acid plus base forms a salt and water. Because it's hydrochloric acid, it's going to be a chloride. Because it's iron hydroxide, it's going to be iron chloride. So we form iron chloride and water. So here's our last 2 practice questions before we go on to look at the reactions of acids and metal carbonates. Once again, read through the questions, pause the video, have a go at them, and then we'll go for the answers. So question 4 is first asking you to name the type of reaction that takes place when potassium hydroxide reacts with hydrochloric acid. So we have an acid reacting with an alkali, and the reaction is a neutralisation reaction. Now there's 1 mark for that. I'd also accept it if you said exothermic, because the reaction would give out heat. Now let's write a chemical equation for this. Now the word equation would be potassium hydroxide reacting with hydrochloric acid to form potassium chloride and water. So when we write a chemical equation, we replace the words with chemical symbols. Now to write the formula for potassium hydroxide, we take the two ions, K plus and OH minus, because they're the same charge, they cancel out. Hydrochloric acid, we know the formula already is HCl, so that will form potassium chloride. So we have K plus and Cl minus ions here, and we need to use that to work out the formula, and the other product is water. So to work out the formula of potassium chloride, I've got K plus, Cl minus. Because the charges are the same, they cancel out, so the chemical formula is KCl. So let's write this in here. Now this equation is already balanced because we have the same number of atoms of each element on either side of the equation. Now for the ionic equation, it's just a simplified form of the chemical equation. H plus comes from the acid, OH minus comes from the alkali, and we form water. So there's 2 marks for this, 1 mark for the left hand side and 1 mark if you realise that neutralisation reactions form water. Now for question 5, you're asked to suggest 2 chemicals you could use to make the salt sodium sulfate. So because I need to make a sulfate, I need sulfuric acid. Now remember, we've learned that we can form salts from acids and bases, and acids and alkalis, and acids and metals. Now it wouldn't be appropriate to use sodium metal here because we've learnt previously in another module that sodium reacts violently with water and acid. So we would need to use a base or an alkali. So we could use sodium oxide or sodium hydroxide. Now we could use sodium carbonate here, and we're going to learn more about this later in the lesson. So we've seen previously that salts can be made from reacting acids and bases together, acids and alkalis together, and acids and metals together. The next way to make a salt is to react an acid and a metal carbonate or metal hydrogen carbonate. Now if you react a metal carbonate or metal hydrogen carbonate with an acid, a salt, carbon dioxide and water is formed. So we can see from this word equation that acid plus metal carbonate forms salt, carbon dioxide and water. And the chemical equations show this clearly. Hydrochloric acid reacts with calcium carbonate to form the salt, calcium chloride, carbon dioxide and water. And if we used a hydrogen carbonate such as sodium hydrogen carbonate and reacted it with hydrochloric acid, again we'd form a salt, carbon dioxide and water. The salt would be sodium chloride here. And this reaction is often used as a chemical test for a carbonate ion, because if you add acid such as hydrochloric acid or sulfuric acid or nitric acid to any compound that contains the carbonate ion, so for example a metal carbonate such as sodium carbonate or potassium carbonate or calcium carbonate, etc., you will get carbon dioxide given off and you will observe lots and lots of fizzing. So therefore it's a chemical test for a carbonate ion. Now this reaction is also used to test for acids sometimes, because if you add a carbonate to an acid, again you observe fizzing because carbon dioxide is produced, and therefore it's a positive confirmation that you'd have an acid. Now this test is particularly important in organic chemistry, where metal carbonates or metal hydrogen carbonates are often used to test for the presence of organic acids such as ethanoic acid. Now in our previous lessons we've discussed in great detail how we can produce crystals of soluble salts by reacting insoluble bases and acids together. Now an alternative to using an insoluble base is to use a metal carbonate, and the method for producing crystals of the soluble salt would be exactly the same. So for example, if we wanted to make crystals of the soluble salt copper sulfate, we could use copper carbonate as an alternative to copper oxide, and we could add the copper carbonate to sulfuric acid, warm it if necessary to speed up the reaction. We would filter to remove unreacted carbonate. The copper sulfate that would emerge through the filter funnel would then be heated in an evaporating basin to evaporate off the water to leave crystals of the soluble salt. We would again tend to only evaporate 2/3 of the water by heating with a Bunsen burner, because we would want to produce large crystals normally for this, and slow evaporation of the remaining third of the water would leave us with large crystals of copper sulfate. Now the following video shows a metal carbonate reacting with a dilute acid such as hydrochloric acid. So if we add the metal carbonate, in this case copper carbonate, you can see that we get lots of fizzing, and we've got a delivery tube here which is going into another boiling tube of lime water, and lime water is a test for carbon dioxide. So you can see that when we add the copper carbonate to the hydrochloric acid, we get carbon dioxide being formed, and we know this because the lime water turns cloudy, and lime water is a test for carbon dioxide. So now let's test your understanding of this with some practice questions. So read through the questions, pause the video, have a go at them, and then we'll go for the answers. So now let's go for the answers to question 1. So we have to complete the word equations here. So our first word equation is zinc carbonate and sulfuric acid. Now whenever you have sulfuric acid, you form a sulfate. So the salt that we're going to form is going to be zinc sulfate, and my other products are going to be carbon dioxide and water, because whenever you add a metal carbonate to an acid, you form a salt, carbon dioxide and water. Now if you've written down zinc sulfate plus carbon dioxide and water, that's worth 1 mark. So in question B, we have sodium hydrogen carbonate and nitric acid. Now there's no difference if you use a hydrogen carbonate or a carbonate, you still will get a salt, carbon dioxide and water. And because it's nitric acid, my salt will be a nitrate, and because it's sodium hydrogen carbonate, it will be sodium nitrate. So my products here are sodium nitrate plus carbon dioxide plus water. For C, we have magnesium carbonate and hydrochloric acid. Because it's hydrochloric acid, I'll form a chloride. Because it's magnesium carbonate, it will be magnesium chloride. And once again, my other products are carbon dioxide and water. Once again, identifying the correct products gets you 1 mark. If we look at part D, we have copper carbonate and sulfuric acid. Sulfuric acid leads to the formation of sulfates, so we're going to make copper sulfate and carbon dioxide plus water. Once again, if you put copper sulfate, carbon dioxide and water, you get a mark here. And if we look at the final question, we have sodium hydrogen carbonate and sulfuric acid. Sodium hydrogen carbonate is going to form sodium sulfate when you add it to sulfuric acid, and the other 2 products are going to be carbon dioxide and water. So there are 5 word equations here, 1 mark for each, a total of 5 marks available. So here's our last set of practice questions. Once again, read through the questions, pause the video, have a go at them, and then we'll go for the answers. So question 2a is asking you to name the gas formed when a metal carbonate is added to a dilute acid. Well, because it's a carbonate, the gas formed will be carbon dioxide, 1 mark for that. And then it's asking you to describe a chemical test to prove the identity of this gas. Well, there's 2 marks for this, so you would bubble the gas through lime water, 1 mark if you said that, and the lime water turns cloudy if carbon dioxide is present, 1 mark for that. Now question 2b is asking you to suggest a chemical test to identify the presence of a carbonate ion. So there's 2 marks for this question. So the first thing you would do is to add dilute acid to this substance, 1 mark for that. And if you observe fizzing, that would indicate you have a carbonate ion. So there's 1 mark for that. I'd also accept it if someone said that they would add the acid and bubble the gas into lime water, and if the lime water went cloudy, that would indicate the presence of a carbonate ion. However, you don't need to do that because fizzing would tell you that you have a carbonate ion. So that concludes this video lesson. So after watching this video lesson, you should now be able to recall how salts can be made from reacting acids with insoluble bases, alkalis and metals, and understand how neutralization reactions can be summarized by a simple ionic equation. You should also understand that metal carbonates react with acids to form metal salts, carbon dioxide gas and water, and be able to explain how crystals of soluble salts, such as copper 2 sulfate, can be obtained by this reaction. Finally, you should understand that the acid-carbonate reaction is often used as chemical test for acidic substances and a carbonate ion. So that concludes this video lesson. So please check out our YouTube channel, Dr. O Chemistry, which has lots of GCSE, AS and A-level videos, and our Twitter site @RadaChemistry.